In this video, I'll be teaching you how to use BoneToPix to convert 3D models into animated pixel art sprites. Over here, I have a new Unity project that I've imported the BoneToPix package into. First of all, you're going to want to go into the BoneToPix package folder, go into Source Files, Scenes, and open the Converter scene. Next up, you're going to need a 3D model to convert from. Over here, I'm just going to use the UnityChan model that's included in the BoneToPix package for testing purposes. So you'll want to go into the UnityChan folder inside of the BoneToPix package. Go into the UnityChan model folder, Art, Models, and just drag the UnityChan prefab over here into your scene. Now, if you're going to be importing an FBX model from, say, Blender or some other 3D software that you're animating your model in, then this is going to be enough. But some models, like UnityChan, are going to have a separate animator they're going to need to drag in. So you're going to want to make sure that your animator is selected there. Now, next up, you're going to want to click on the BoneToPix converter object in the hierarchy over here, and you're going to find the BoneToPix script attached to it. Now, over here you're going to see multiple fields for the various settings that you can change, and the first field is called conversion target. Over here we're going to want to drag in a reference to our model, just like that. We're going to talk about the other settings later. Since we're going to keep our settings on default for now, you can just click begin conversion, and your model is going to start animating, playing through all the animations attached to it. You're going to want to make sure to not click away from the Unity window while this is happening, otherwise the conversion will have to pause. And there we go, done. Now if you're going to check your output folder, you will find a new folder inside of it containing your generated sprite sheet, normal map, the generated palette, and a preview material, along with a folder for the generated animation clips and an animator containing all of the clips. Also, if you're going to check the scene hierarchy on the left, you will see that a new game object has been created that is using our generated sprite sheet and preview material. Now, to see how our sprite turned out, we're going to create a new point light. Move it to the side, make sure that it is on a higher Z position than our sprite. And if you click on the generated sprite and go into the animation window, you can play through the animations and see whether the conversion was successful. At this point, you can decide whether or not you're satisfied with the colors and maybe modify the generated palette with some manual colors to get a better result. Now let's talk a little bit about the main settings available in BoneToPix. So over here, going through all the fields one by one, the first one is the reference to the model that we just dragged in. Then we have a reference to an advanced settings scriptable object that we're going to talk a bit later about. A reference to the camera being used to convert from. You can just leave this on default. Cell width and cell height, determining the size of each frame of animation. An option whether or not you would like to draw an outline. Over here we have a choice of what type of palette you would like to apply to your output sprite. The default is you can auto-generate a palette based on the colors in your original model. And you can choose the total number of colors that you would like to have in the generated palette. Another option is to not use a restricted palette at all. And the final option is to just provide your own palette. One way that you can easily build a palette is to just use the auto-generate option first, convert your sprite, and then check your output folder, and over here you'll find the file for your generated palette. You can open it in whatever editor you would like, take a look at it, and modify the colors that you would like to change. Let's say maybe we want this blue to become red for whatever reason. And there we go. You can then save that, drag it in as a reference in the manual palette field, and run the conversion again. And finally, over here we have an option for the type of lighting that we would like to have on our output sprite. The default is to just generate both a flat color base sprite and a normal map, which will allow you to have dynamically lit sprites. Otherwise, if you'd like to have your light be baked into the sprite itself, you've got two options for that, with either cell shaded lighting that will sort of give you a more cartoony look to your output sprite with less levels of light, or just generic lighting, which will give you sort of smoother lighting. Now let's go over a little bit over the advanced settings. If you just double click on the scriptable object reference over here, you're going to find a bunch of extra options over here that you can modify. So you can modify the output path inside of your asset folder. You can modify the sprite pixels per unit value that your output sprites are going to have. You can play around with the intensity of the noise pixel detection algorithm. You can change the consolidation threshold for the palette generation. Essentially, higher values over here are going to make more similar colors get consolidated into a single color in your output palette. Essentially, if you'd like more contrast in your sprite and less smooth gradients, you're going to want to drag this to a higher value, and if you would like smoother sprites with more gradients, you should go for a lower value. You can modify the dithering texture being used. If you double click on this one, you'll find a folder with a few other options that you may want to use, including a 4x4 and an 8x8. You can experiment with those and see the different results that you're going to get with each of them. Then there's also similar options for whether or not you want to use dithering, the dithering intensity and the dithering texture for sprites using the cell lighting conversion. If you're using an outline on your output sprite, you can choose whether or not you would like it to use lighting or not, and you can choose the outline color. You can also choose whether or not you'd like to apply the cell shading algorithm to your normal map output. By default, this is turned off and you'll get smooth normals. You can also change the cell shading lookup used for both regular dynamic lighting conversions and for cell shaded baked lighting conversions. If you click on these again, you'll be sent to a folder containing a few other options. Essentially, lookups with more visual steps are going to result in more steps in your lighting. So if you want smoother lighting, you should have a texture with more steps, and if you would like more cartoony lighting, you should use a lookup with fewer steps. There's also references that you can change to the materials being used for each type of conversion. Most likely you're not going to want to change those. Same for the references to the shaders.